Hi, my name is Renee and I'm here from the Science Schoolyard, and I am so glad that you're here with me today. Really, I'm here to actually help you use your science lessons to add practices and ideas about engineering design that's really necessary for our learners to be natural engineers. They already spontaneously love to build with blocks or even sandcastles at the beach, and as we find ways as our learners get older to add more complex design projects to their ability to be problem solvers, we want to make sure that we continuously look for positive growth mindset and their ability to problem solve. So I'm here to help you focus on engineering through the scientific experiences that are relevant to their lives. And so let's help our diverse classrooms deepen their science knowledge and find ways for science to actually be relevant to their lives and their future, and to be able to engage them in innovative and creative challenges as we explore this through STEM. So what does engineering design look like in NGSS? Well, first, in NGSS, engineering design is really a way for us to be able to take things like life and physical and earth and space science and begin with an engineering practice. And so when we look at these standards, we need to understand that students can demonstrate their understanding of science through the applications of engineering practice. We also want to look at the idea that even if you do not use NGSS, we can also include separate standards that you have to work on for engineering design, whether it be K2 or 3-5 grade levels. So when we look at something like a multi-pronged approach, we can include engineering design both as a set of practices or as a set of core ideas, which is really consistent to any science framework that you use. So in grades K2, engineering connections, we have to look at the earliest grades that are introducing students to what we call problems as situations that people want to change. They can use tools and materials to solve simple problems. We can have them use different representations to convey like solutions and compare different solutions to a problem. And we want them to determine which solution might be best. So students in these grade levels are not necessarily expected to come up with original solutions. Although original solutions are always really good, we really want them to start really the basis of problem solving as a team, as an individual, and look for ways to be able to use that positive growth mindset as they continue to emphasize the defining, the developing solutions, and the optimizing their solutions and evaluating actually what they did. We know that in 3rd through 5th grade, those upper elementary grades, engineering design actually engages students in a more formalized problem solving. So students define a problem using basically criteria for success. And we look at constraints or limits or even possible solutions to the problems that were given. Students can research and they can consider multiple possible solutions to a given problem. And what we might want them doing is really generating and testing solutions as they become more rigorous, as the students learn to really optimize solutions and learn to revise them in several times, or even to be able to look at what were the problems that existed and possible design outcomes in the future. We know that students at the upper grades can really look at specifying criteria and constraints that are possible solutions to a simple problem that they must meet. And we also want to add some of that research and exploration of possible solutions because it allows them to optimize and improve on solutions based on really results of simple tests, including really failures as well. So as we start looking at really performance expectations and ways to incorporate engineering design, we really could look at something like NGSS alignment and really think about the practices that we have in science, like asking questions and defining problems, or even using models or conducting investigations. We also really want kids to be able to analyze data using mathematics or constructing an explanation for our design solutions, or even arguing for evidence. We also want them communicating those bits of information that they're finding. And that's really helpful in any type of science curriculum. We also want to look at, especially with NGSS, these cross-cutting concepts such as patterns or causation, or even scales and systems. We can look at energy or structures and functions, and stability and change. And these cross-cutting concepts allow us to be able to start ways to add engineering design into our lessons. So if we were looking at the disciplinary core ideas, so if we were looking at physical science or life science or even math or language arts, social studies, and then of course our engineering and technology component, we can see that immersing our students in science and engineering design practices is really key to them being able to develop relevant cross-cutting concepts and be able to use those core disciplinary subjects. It's really a great tool, a great avenue for being able to do that. So as we look further into being able to look at performance expectations in whatever program you use, we really like to identify a question and propose an explanation when we want to look at engineering design. And as we have our littles or our bigs perform an experiment or test a hypothesis, we can base those results on some way to be able to add our design solutions. So I'll give you an example. So if I was teaching kindergarten, I know one of my standards has me really looking at ways to be able to, say, for example, use tools and materials to design and build a structure that will reduce the warming effect of sunlight on an area, which is KPS 3-2. I can have my students build a structure that will keep the sun not shining on maybe a Beanie Baby or a figurine. They could build maybe a hat that would allow them to be able to keep the sun out of their eyes. And as our upper elementary grades are looking at performance expectations, say for example in 4th grade, when we look at waves and what they can do or patterns of earth features that can determine using maps, we might be able to look at energy, for example, and making observations to provide evidence that energy can be transferred from one place to another, or to ask a question and predict outcomes. If we were looking at maybe tying an NGSS to an engineering design, we might have our students making a flashlight to be able to see how we can be able to transfer light, or maybe make an instrument and how to be able to transfer sound. But these are all ways that we can start integrating all of our science concepts into being able to add that engineering component to our classroom. So what I have for you today is I want you to grab your free ebook. This allows you to have a guide for the foundations of the engineering process. And included in that are some posters that you can use to hang in your room that show the design process as we go through asking and imagining and planning and creating and improving. We know this is really important to have visuals for our students as they are developing in their ability to add their problem solving, as well as steps that you can take as you start building in some engineering activities into your science lessons. So again, I'm so glad that you are here joining me here in the Science Schoolyard as we find creative challenges and explore them through STEM in our science lessons. Please make sure you stop back at the Science Schoolyard blog or follow my Instagram. You can see all of the ways that I'm able to take my science lessons and integrate some great engineering activities as well.